Ever wonder where sugar comes from? Of course you have. When it comes to sugar, the men and women at U.S. Sugar Corporation know a thing or two about sugar. Starts with sugarcane. During the 2019-2020 season, U.S. Sugar Corporation produced over 8.2 million tons of cane. That's tons. Like most crops, sugarcane is seasonal, runs about 240 days per year, starting in early October, running usually through May of the following year. That's 240 days of continuous cane grinding. Hi, I'm Greg Serio, your tour guide today. I'm here to take you on a video tour of the milling department here at U.S. Sugar. I'm excited to show you what it means to go from cut to crush. Let's go check it out. From the field, the sugarcane is cut and loaded into a rail car. Sugarcane is comprised of approximately 70% water, 13% sucrose, or your sugar, and about 12% fiber, also known as bagasse, and the other 5% is stuff like dirt and leaves and stuff that gets added into the rail car. All parts of this cane can be used and recycled back into the process of producing sugar and helping grow more sugarcane. As the billet moves through the milling process, it'll produce about 3.5 million gallons of water each day. That's over 5 Olympic-sized swimming pools worth of water. The fiber, or bagasse, left over will eventually be used to generate power. 1 ton of bagasse is the equivalent of 50 gallons of diesel fuel oil. The power generated from the bagasse is the same power that will be used to power the milling department. The sugarcane arrives via railcar. When getting cut in the field, it's cut to about an 8-inch length. These 8-inch lengths are also known as billet, or sugarcane billet. When the billet sits too long, bacteria can develop, which is why it's important to move it from cut to crush as fast as possible. Once you start breaking into this actual sugarcane, it creates more area for bacteria to grow, exposing it. So that's why it's really important to get it from cut to crush in approximately 6 hours. So where do we start? We start here in the control room, the heartbeat of the sugar milling process. Each station represents a virtual, real-time representation of what's actually happening in the milling process. It's like having a live feed to each individual department that's producing sugarcane. From start to finish, the process can be monitored here to see any impending issues or gaps, and it can be communicated quickly. Here at the Clewiston Processing Facility, there are 4 main departments: milling, juice processing, refinery, and power generation. The mill is comprised of 2 sets of milling tandems, the B and the C tandem, each tandem having a dedicated set of equipment to process incoming rail cars full of sugarcane. The A tandem was decommissioned in 2006, paving the way for C tandem to start producing. The basic process is to dump the cane billet onto a conveyor. The conveyors will move the cane billet into a series of rollers that will crush the cane. Each roller is crushing remaining water and sucrose from the cane, leaving only fiber or bagasse left to convey into the power generation department. These series of rollers work in a row, or in a tandem, hence the name tandem B and C. The first part of the milling process is when a string of rail cars enters either the B dump or the C dump. Each dump letter, B and C, matches the corresponding tandem that these cane billets will eventually be processed through. To give you an idea of the size of each one of these rail cars, we can only put it in way of tons. That's 2,000 pounds per ton. Each rail car contains 38 of these tons per car. Close to 215,000 of these rail cars find themselves here on either one of these B or C dump tables. What does a string of 215,000 rail cars look like? It would be a string of cars long enough to run from Clewiston, Florida to Ontario, Canada. The B dump is able to dump up to 368 cars per day, which will grind approximately 14,000 tons of cane per day. These cane billets will eventually end up in the steam-powered B tandem. C dump has a slightly larger capacity where up to 632 cars are dumped, grinding roughly 24,000 tons per day. These will eventually end up in the hydraulic-powered C tandem. The C tandem produces roughly 10,000 more tons per day as compared to the B tandem. Once the car reaches the dump table on either dump, the tag reader on each car will tell when it was loaded, the variety of cane it is, and where and who loaded it into the rail car. The weight is recorded before and after the cane billet is dumped onto the conveyor. Once the cane is dumped, it'll move through a series of conveyors that are engineered to move the cane billet in a consistent level manner into the mill tandems. Various rotating rake assemblies positioned on each dump and over the top of the conveyors full of sugarcane, preventing bottlenecking and ensuring the billet feeds on an even level as it passes underneath various magnets. Sometimes a piece of metal can get stuck in the process from the field by accident. These powerful magnets can pull metal directly off the conveyor and remove this metal that may cause damage to downstream equipment. After passing through the magnet, the first stage of preparation can begin. The cane is fed into a set of knives that cut the billet into smaller pieces. The C tandem knife set is powered by a 4,500 horsepower motor, and the B tandem knife set is powered by a 1,500 horsepower motor. Once cut into smaller pieces, both B and C tandems have an identical shredder that have 192 hammers that are driven by a 6,000 horsepower steam turbine. These shredders then pummel the sugar cane into a finer material. This finer material can then be crushed in a series of rollers that comprise each mill. Each mill is aligned with multiple mills forming the tandem of mills. In the event a piece of equipment malfunctions, that piece of equipment is de-energized. It's locked out based on the lockout-tagout safety procedure. As part of that lockout-tagout process, one must travel to one of the many MCC rooms, or Motor Control Center. Each piece of equipment has a specific lockout-tagout procedure.
Lockout-tagout is when you de-energize the system. You take away the electrical power or the energy source away from the equipment, whether it's air, hydraulics, whatever it is, you're locking those equipment out so that it cannot operate. You're basically locking anything that will move or anything that's going to cause something to move if you cycle a valve or if you're working on the equipment. That way it can protect you while you're in that equipment. If we have equipment failure, basically what they're supposed to do is you will actually call your supervisor. The supervisor will bring you the procedures. There's an actual documented procedure on how to lock and tag out each piece of equipment. The supervisor would lock and tag each one of those pieces of equipment by the checklist, and the employee would put his lock on a lock box to show that he verifies exactly what the supervisor had done.
These mills have compound maceration, which is where the last mill gets fed water and the previous mill gets backfed a juice-water mixture. Each previous mill getting the juice-water mixture pumped upstream is increasing its sucrose concentration as it goes. The juice and fiber from the first two mills goes through a set of rotary juice screens. This separates the fiber from the juice. The fiber then returns to the mill via a set of corkscrew conveyors, and juice goes to the juice processing department of the plant. Both B and C tandems supply close to 7,500 gallons of juice per minute to the juice processing section of the plant. So, what exactly is a mill?
Okay, so the C tandem is powered by a series of 800 horsepower electric motors driving Denison hydraulic pumps that provides the power to the Hagelin hydraulic motors. And on the B tandem, the smaller tandem, that one's driven by a turbine that drives a high-speed gearbox into a low-speed gearbox into a mill coupling into the mill rolls itself. What makes it a tandem is it's got a series of mills that consist of 4 mill rolls per mill.
With the B tandem having 7 total mills, and the C tandem having 6 but with larger diameter mill rolls. The machine shop here at US Sugar produces and maintains all of the equipment needed in the milling process by doing fabrication, maintenance, and repair all at the same facility.
So we have basically 2 big shops here. The C tandem makes all the C tandem rolls and prepares them for the C tandem. It's got the lathe in there, it's got the weld shop in there for putting the, after we get done machining it in the lathe, we put it over in the Zucar tent. We have a B and a C shop. We do all the components from the dump all the way to the bagasse belt. I have to service them all, prepare them all for the next crop coming up so that we have the parts ahead of time so that when they tear the mill tandem down, they have the parts to put right back into the mill. So that's my goal as a supervisor over the machine shops, is to have these parts ready for the guys and have them ready correctly. And because if we have to purchase the parts, it takes a long time by boat to get them. So our goal is to have everything that they need ready.
Essentially, the large rollers used to crush the cane in each mill comes to the machine shop to get refurbished and fabricated back to its peak performance specifications. Using the rail system, shaft rollers and other various forms of large equipment are brought into the respective machine shops utilizing overhead cranes and train cars. Once the roll makes it into the machine shop, the roll is carefully placed on the respective lathe dedicated to that roll's tandem. The biggest difference between these parts is size. The C tandem mill rolls are noticeably bigger when compared to those from tandem B.
On the B side, we do the exact same thing. The difference is the mill rolls on the C side are up to 59-inch diameter, weighing 75, 80,000 pounds, just the roll itself with the shaft and the shell. On the B side, the shaft and the shell's like around 45,000 pounds. So basically the rolls are the same, just size is different.
A lathe is a piece of metalworking equipment that rotates a piece of material, also known as the workpiece, while a stationary cutting tool is applied to the outside diameter as the part rotates. In this case, the workpiece is the mill rolls. Bruce, can you explain what carbide is?
So this is an 1.25 inch piece of carbide. It's really hard. It's harder than the cast iron steel that it's cutting. It basically turns the outside diameter of the mill rolls so we can turn them back down to an even finish all the way across to a certain diameter that we want. And then this insert that we have here is a 40-degree diamond insert. We use both sides of it. It's also carbide, which is really hard. It's made for turning the cast iron that we have on the mill roll, removing all the rust, removing the bagasse, removing the weld that's left over from the roll when it was made new, and all the weld that's put on during the time of it in the mill tandem.
These pieces of carbide are inserted into a stationary stick tool that's made of hardened tool steel. This tool is properly positioned to move down the length of the mill roll, removing undesired materials. Once the mill roll is finished on the lathe, the roll is then lifted with the overhead crane and positioned in the Zucar welding tent.
We get done machining it in the lathe, we put it over in the Zucar tent that we've invested a lot of money in to make it safe for the employee to be able to apply weldment to the roll. We put a base coat, a teardrop on, and a splatter weld, and what that's doing is that's giving the mill roll traction to grab the cane to grind it. Welding machines that we have are automated welding. They apply the base, the teardrop, and the splatter weld. We use a buffalo weld that's a base coat that's around 45 Rockwell, and then we use a teardrop and a splatter weld, which is a C&O wire that we purchase, and it's all put on by the Zucar machine.
Once the cane makes it to the end of each tandem, the fiber proceeds via conveyor into the power generation department. This bagasse can be used to fuel the boilers to produce around 1,450,000 pounds of steam per hour, which will be used to produce power. And that about sums up how we go from cut to crush through the milling department here at US Sugar. Once the cane is received from the agriculture department, the process of milling can then start at the dump. It arrives at your dump and conveys into the next process. That bagasse is then processed through a series of mill tandems. But through that mill tandem, you have to think. This is the start of feeding into the next process. The mill here at US Sugar works with other departments to renew and recycle every step of the process. So it's important to understand when you mill sugarcane, you're pulling out the juice that goes to the department that extracts the actual sugar. you're producing fiber that goes to the power generation where it generates more power, and you're then able to take the recycled water and use that to keep the production of cane going through the form of more sugar cane. So we hope you enjoyed this tour of the milling process here at US Sugar in Clewiston, Florida. I'm Greg Serio, and on behalf of US Sugar, thanks for watching.